Greetings to all. In today's session, we are going to discuss about the intermediate chemistry, which is helpful to crack your international entrance exam or any competitive exam on the international floor. So in addition to that one, JEE Advanced and JEE Mains examination for technical stream entrance exam like engineering in IITs and NITs, NEET entrance for medicinal entrance exam throughout India, Telangana-MCET and AP-MCET examination for engineering entrance in Telangana and Andhra Pradesh. In addition to all these, if you are preparing for any competitive examination, the content is going to discuss here will be very much helpful to you. Let's enter into our today's content. Question number 1. What is the IUPAC name for the following compound shown here? So this is the compound given. We have to find out its IUPAC name. Here, if you observe, the compound is given with the oxygen linked with alkyl and another alkyl in both the ends. So that this is the functional group called ether. For ethers, IUPAC general nomenclature will be ethoxyethane. Ethoxyethane, ethoxy will be the shorter chain, ethane will be the, alkoxy will be the shorter chain, alkane will be the longer chain, right? So in that case, here you can observe this is the kind of compound provided here, ROR prime. Alkoxy-alkane, the common IUPAC nomenclature for this compound will be alkoxy-alkane, and this is the kind of ether. This is the kind of ether compound over here. So in this compound, the parent chain will be 1, 2, 3, 4. 4 carbon chain obviously will become the longer and parent chain, and this ethoxy will become a side chain, alkoxy, right? So that we can say ethoxybutane, being 4 carbons, so that we have to mention butane. All carbons are saturated, N will be the suffix over here. The final IUPAC name of the given organic compound will be ethoxybutane. So let's enter into our question number 2. Here, so many compounds are provided. This is the question which is imbibed with so many contents, so many concepts over here. If you know so many kind of fundamentals, then only we can answer this kind of question, right? Find out the type of compounds from the following. What the relation you can find among them, that relation we have to retrieve. Okay, here oxygen 16 is there, oxygen 18 is there, O2 is there, O3 is there. O2 is called molecular oxygen, O3 is called ozone. And oxygen with 16 mass number, 8 atomic number, nitrogen with the 14 mass number, 7 atomic number, carbon with 12 atomic mass and 6 atomic number. So these 3 compounds also having one certain similarity that we have to find out. And another is neon 2210, sodium 2211. This is also another kind of similarity we have to find out. So these many options are provided, and this kind of compounds, whatever given A, B, C, D options, what kind of examples they belongs to, we have to find out. Let's go with one by one. If you go with question number A, oxygen 16 and oxygen 18 are there. Oxygen 16 means mass number of oxygen atom is 16, mass number of second oxygen will be 18. In that case, you can find 8 protons over there, 8 neutrons over there, and 8 electrons revolving around the central nucleus. The set of electrons are 8 again. So this is oxygen 16 isotope. If you go with second O18, in that O18, you can find 8 protons. Proton count remains the same for both O16 and O18, but there is only the difference in this number of neutrons. Number of neutrons got rise to 10 neutrons over here, and the number of electrons remains same again. 8 electrons are revolving around the central nucleus. The set of electrons are 8 again. So that only the difference you can find number of neutrons. So this kind of example is the part of isotopes. Now let's discuss what is mean by isotope. Any nuclide with the same atomic number. If you say oxygen atomic number is 8 itself, so that atomic number remains same, but only differs in this mass number. Mass of first oxygen is 16, second oxygen is 18. That's why mass number got varied. These two kind of isomers are called isotopes, right? So here, isotopes tends to be less stable and can have significantly different nuclear properties. Here, this is about the isotopes. The kind of relation between oxygen 16 and oxygen 18 is isotopes. Okay. Here, oxygen with the same atomic number but different mass number, hence we can say isotopes. Option B is having O2 and O3. O2 and O3 are having the relation of allotropic forms. Okay, O2 is having diatomic oxygens, O3 is having triatomic oxygens. Three oxygens are joined like this, right? So if you go with allotropes, what will be the definition? Two or more forms of the element that have the distinctively different physical and chemical properties. Though both the molecules are made up of oxygen itself, the core we have oxygen, but here the oxygen arrangement is different, here the oxygen arrangement is different. If you see O2, that is a diatomic, O3 is the triatomic molecule and arrangement is entirely different. So that we can say they differs in their physical property as well as chemical property, but made up of same kind of element. Those are called allotropic forms. The simplest example, diamond is the allotrope of graphite. So here is the example provided. Allotrope chemical structure is entirely different, so that their physical and chemical properties also varies. The relation between these two molecules is the allotropes. Allotropes of same element but different physical and chemical properties. Let's go with the option number C, where oxygen 8 atomic number, 16 atomic mass, nitrogen 7 atomic number, 14 atomic mass, carbon 6 atomic number, 12 atomic mass are provided, where you can find the oxygen with the protons of 8, nitrogen protons of 7, carbon protons of 6, whereas neutrons in these three elements are provided with 8, 8, 8. So that this kind of relation is called isotones. The relation is said to be isotones. Isotones are defined as any atom having any atoms of different elements. Elements are not similar. Here it is oxygen, nitrogen, and carbon. So that different elements but having same number of neutrons. This is reverse to isotopes. Isotopes are different neutron number will be there. Isotones, same neutron number will be there. Carbon and nitrogen both are having 8, 8 neutrons in that, so that we can say both are, all three are isotones only. This is the way we can give the relation between these three elements. Go with the last option, option number D, where we have neon, noble gas. Atomic number is 10 and atomic mass is provided with 22, where sodium is having atomic number 11 and atomic mass is 22, right? So if you observe, both the elements are different. Atomic numbers are different, but their atomic masses are similar. In that case, we can say these are called isobars. This is another term we can say. Isobars of different elements with the same atomic mass and different elements. Neon is the isobar of sodium. Argon is the isobar of potassium, where you can find same atomic mass, but different elements are there. Elements are different, but mass number remains the same. Those are called isobars. So in this way, let me confine oxygen 16 and oxygen 18 are called isotopes. Different neutron number count will be there. O2 and O3 are called allotropes. Oxygen, nitrogen and carbon having same number of neutrons called isobars. Neon and sodium are having same mass number called isobars, right? This is the way we can answer the question number 2. Let's move on to question number 3. Question number 3 is given from nuclear chemistry. The radioactive nucleus is taken as X. Its atomic number is Z. Atomic mass is A. Undergoes spontaneous decay in the sequence. X, Z, A fragmented, decayed to give Z minus 1. And here X now converted into B, right? So here, if the atomic number is Z, after the decay, that is converted into Z minus 1. And further decay got Z minus 3 and B turned into C element. Further fragmentation Z minus 2. Z minus 2 is obtained so that C converted into D, right? Where Z is the atomic number of the element X. The possible decay particles are these kind of series of reactions carried over here in this radioactive nucleus decay, so that Z minus 1, Z minus 3, Z minus 2 are the final products in the series. What kind of particles are evolved, what kind of particles got emitted during the decay process, we have to find out. In order to get that one, if Z to Z minus 1, there is a decay of beta plus. Beta plus is nothing but electron. So if electron lost, so that atomic number will be decreased by unit 1. So we can say beta plus over here. And alpha particle, if lost, alpha particle nothing but helium nucleus. Helium is the noble gas. So that atomic number will be 2. So if alpha lost, Z value will be decreased by 2 units. Already Z minus 1 is there. If alpha lost, it will become Z minus 3 now. Okay. Then from Z minus 3, if beta minus got removed, beta particle removed, electron removed. By the loss of electron, what happens? Atomic number got increased by 1 unit, Z minus 2 it will be. Atomic number got increased by 1 unit, Z minus 2 it will be. So that the correct series of decay particles are beta plus first decrease, alpha 2 decrease, beta minus increase by 1 unit. This is the way we can answer. The correct option will be 3 for question number 3. Beta plus alpha, beta minus is the correct answer. Let's move on to question number 4. This is the question given from the fundamentals, polar molecules. Okay, types of bonding. We can say types of bonding. Here bonds are made up of either ionic, covalent, coordinate, covalent, like that. Okay, so if covalent bond is taken into the consideration, in that polar bond will be there, non-polar bond will be there. Here the question regarding polar molecules are the molecules. If you are taking polar molecule, what kind of condition should be satisfied? Having zero dipole moment. Zero dipole moment means there is no shifting of electrons from one end. So being if the molecule is symmetrical, all the electrons are equally shared, that then you can find a dipole moment will be zero. That is called non-polar. So that this is not the correct option. Acquire the dipole moment only in the presence of electric field. No. Polar molecules, slightly electrons got displaced, so that we can say dipole moment got generated every time, not in the presence of electric field only, right? Acquire the dipole moment in the presence of magnetic field is absent. In the absence of magnetic field, acquires the dipole moment only when the magnetic field is absent, not like that. This is not related with the electric field and magnetic field effect. Rather, it is a permanent electric dipole moment. Always dipole moment is given. Dipole moment is calculated by charge by distance and measured in dBi units, right? So polar molecule always consisting the displacement of electron towards one of the atom of higher electronegativity. That's the reason why they are acquiring positive pole and negative pole partially. Hence, they are acquiring permanent electric dipole. That is given here, explanation provided over here. Polar molecule is a molecule containing polar bonds, where sum of all the bonds dipole moment is not zero. So certain dipole moment will be there. So that dipole moment 0, that is not suitable for this question, right? So polar bonds form where there is a difference between the electronegativity. If two binding atoms are of different electronegativity, then displacement of electron towards one end is possible, so that we will get polarity. Polar molecule also forms a spatial arrangement of chemical bonds, more positive charge on one side, more negative charge on one another side. Simply explained with this molecule called water. H2O is a polar molecule where hydrogens are least electronegative. Oxygen is more electronegative. That's the reason why the shared pair of electrons got displaced towards oxygen. Hence, oxygen experiences more electron density denoted with the partial negative, whereas hydrogens are acquiring partial positive charges. This is called a dipole. Generation of charges, generation of positive pole and negative pole within the molecule is called a polar bond. The correct suitable option for this question number 4 will be having permanent electric dipole moment. For question number 4, option number 4 is the correct answer. Let's move on to problem number 5. This is the very lengthy question, we can say, and the question is given from inorganic chemistry, and purely it is related with the metal hydrides and also metal hydrides, purely metal hydrides only. Fine. Sodium hydride with the water liberates oxygen gas, right? Whenever sodium hydride is treated with water, the release of hydrogen gas is possible. This is one of the statement they are providing over here. Methane, silane are the examples of electron precise hydrides. Electron precise means they are acquiring how many electrons actually required, right? So this is the correct one only. Ammonia, water molecules are electron deficient, they are saying, but they are sufficient in nature. Hydrates of beryllium and magnesium are polymeric in nature. This is the correct one only, correct explanation only, right? They are also provided in Telugu. సోడియం హైడ్రైడ్ నీటితో ఆక్సిజన్ వాయువును విడుదల చేస్తుంది. మీథేన్, సిలేన్లు ఎలక్ట్రాన్లను ఖచ్చితంగా గల హైడ్రైడ్లకు ఉదాహరణలు. అమ్మోనియా నీరు అణువులు ఎలక్ట్రాన్ కొరత గల హైడ్రైడ్లకు ఉదాహరణలు. బెరీలియం, మెగ్నీషియం హైడ్రైడ్లు పాలిమరిక్ నిర్మాణాలు కలిగిన హైడ్రైడ్లు. Among all, only option number 2 and 4 are correct answers, so that we can say 2 and 4 are correct statements for the given central metal hydrides. Let's see how can we explain. Let's go with one by one. If you go with sodium hydride with water liberates oxygen. Any metal hydride upon treating with water, hydrolysis of any metal hydride gives rise to hydrogen gas, but they are saying oxygen, so that this is not correct explanation. Hydrogen will be liberated from the metal hydride upon hydrolysis. And the second one will be methane, silane are examples of electron precise hydrides. How many electrons required, those many electrons are there. Exactly correct. How can we say? So if you go with methane, it is of tetrahedral geometry with the carbon containing 4 hydrogen atoms in the regular tetrahedral geometry, where carbon surrounded with 4 covalent bonds, and you can count 1, 2, 3, 4, 5, 6, 7, 8 electrons are there in the bonding form, so that methane is perfectly satisfying octet rule. If you go with silane, silicon tetrahydride, if you see, again it is the tetrahedral geometry. Around the silicon you can find 4 hydrogens in the tetrahedral corners and 8 electrons, so that silane also octet. Hence we can say both are the examples of electron precise hydrides, where electrons are sufficiently bonded. Octet is the stable configuration for any kind of compound. Acquiring octet is the more stability, so that both are electron precise hydrides only. And the third one is ammonia and water molecules are electron deficient. Electron deficient means less than octet if present, those are called electron deficient. If you see ammonia is made by 4 bonds. In general, sp3 hybridization, one of the bond with hydrogen, 2 electrons, 2 electrons, 2 electrons with 3 hydrogen atoms. Another electron pair is resided in another tetrahedral corner, so that we can say tetrahedral geometry. And if you locate the electrons upon the nitrogen, that is a pyramidal in shape. Okay, if you count the number of electrons, 1, 2, 3, 4, 5, 6, 7, 8 electrons are resided around the in the vicinity of nitrogen, so that we can say it is octet, completely fulfilled and stable in nature. If you go with water also taken over here, water oxygen is in sp3 hybridization with the 2 bonds with the hydrogens, and more 2 lone pair of electrons are present in the 2 tetrahedral corners. The geometry will be tetrahedral. If you go with its shape, we can say bent. If electrons are excluded, electron pairs are excluded, only bonded atoms are considered, that will be a bent molecule. Still, it contains 1, 2, 3, 4, 5, 6, 7, 8 electrons. Again, it is a kind of octet. We can't say these two molecules are electron deficient because octet got perfectly satisfied over here. So that these are highly sufficient in nature in terms of electrons. So these are electron sufficient hydrates only. Let's go with the another one. Hydrates of beryllium and magnesium are polymeric in nature. Beryllium is having vacant orbitals on its vicinity, on its surface, so that they're able to form a bridged hydrogen bonds like this. So such a bridging is available in a polymeric form. We can extend these bonds for several longer polymeric chains, so that we can say they are forming polymeric structures. And in the similar way, being beryllium and magnesium are of the second main group elements, both are having same kind of nature, and they are able to give the bridgehead hydrogens in order to extend their polymeric chain. So this is the statement provided for the central metal hydride. 4 will be the perfectly correct answer. Only the statements satisfying are option number B and option number D. Option number D. So that 2 and 4 are perfectly explaining the right statements about the central metal hydrides. So for question number 5, option number C is the correct answer. Let's move on to last question of the session, right? This is the question given from atomic structure. The radius of third orbit of hydrogen atom is R picometers. The radius of second orbit of helium plus ion in picometers to be calculated. హైడ్రోజన్ పరమాణువులో మూడవ కక్ష్య వ్యాసార్థం ఆర్ పీకోమీటర్స్ అనుకున్న హీలియం ప్లస్ అయాన్ యొక్క రెండవ కక్ష్య వ్యాసార్థం ఎంత పీకోమీటర్స్ లో, రైట్? 4 options are provided. Among all, 2/9 R is the correct answer. Let's see how can we calculate this kind of problem, right? So here, this is the problem provided. For hydrogen atom, its third orbit radius is given as R picometers. R picometers is called radius of the hydrogen. So it's a formula. In order to calculate the radius of hydrogen, the formula is n square by Z into 0.529 angstroms. N denotes in which orbit the electrons are laying. Z is its atomic number. 0.529 is the constant parameter. N means what? In which orbit the electrons are revolving? Third principal quantum number. So that we can say 3 to the power 2, 3 squared. And atomic number of hydrogen is taken as 1. 3 squared by 1 into 0.529 angstroms. 3 square can be taken as 9, and divided with 1 is nothing but 9 itself, into 0.529. This is the equation number 1. This is regarding hydrogen. Now let's move on to helium plus. Helium is the noble gas whose radius is calculated by same formula, n squared by Z into 0.529 angstroms. And here the radius of second orbit you have to calculate. That's why n can be taken as second quantum number, 2 square by Z. Helium is atomic number 2. So that Z atomic number taken as 2 square by 2 into 0.529 angstroms. 2 multiplied with 2, that will be 4. 4 by 2 into 0.529 angstroms. This will become equation number 2. Now we are going to divide equation 2 with equation 1. When equation 2 is divided with equation 1, radius of helium plus by radius of hydrogen is equal to hydrogen radius, helium radius is given by 4 by 2 into 0.529. 4 by 2 into 0.529. And R means what? Hydrogen. Hydrogen term is given as 9 into 0.529. 9 into 0.529. If you see this, 0.529 is there in the numerator and as well as denominator. We can cancel out these two terms. Then the concised equation will be 4 over 2 into 9. 4 over 2 into 9. 2 into 9, nothing but 18, 4 by 18. Here in the denominator, we have R. R is nothing but radius of the hydrogen atom in the picometers. So that radius of helium is equal to R is coming this side, so that it will become 4 by 18 R. If you go with the calculation in order to simplify this term again, you can cancel out with the 2. 2 twos are 2 nines are 2 by 9. 2 twos are 2 nines are 2 by 9, and R remains 2 by 9 R. Radius of the helium place is given by 2 by 9 R, that is provided in the option number D. For question number 6, option number D will be the correct answer. By this, we completed the entire session. And these are the questions which are calculated, which are collected from the recent previous year examination. In 2023 itself, the conducted NEET exam. 2023 itself conducted EAMCET examination Telangana, and also all the remaining platforms got searched, and proper information got collected and provided over here. I hope the session will be very much helpful for your entrance exams and competitive examination as well. Hence, I am requesting you to kindly like the channel, comment which question is really helpful for your preparation, and share with the aspirants whoever preparing for the exam seriously. Definitely, it will help to crack the examination. Subscribe the channel in order to get more such kind of videos over here. And thank you very much for your patient listening. Thank you one and all.